Alright, hi guys, so in this video we're going to be covering the equations of that include radical or rational exponents, but specifically we're going to be talking about solving when these equations are quadratic in form. So these problems are problems that follow the format of a quadratic equation. So if you look at the first term, right, it's just x. You're saying, well, normally it would be x squared. Well, remember that a quadratic will be in the form ax squared plus bx plus c, right? So this is the x term, and then this is something squared, right? So in this case, the x is actually square root of x. So that value, right, squared would be x. So you could actually just replace, let's say u is the square root of x. And so if u is the square root of x, then u squared would be square root of x squared, which would just be x. So you could see here, we're going to be able to replace this with u squared, and we're going to be able to replace this with u. So replacing this question, we have u squared plus 2 times u minus 3 equals 0. Now we could solve it like a regular equation, right, with the variable u. This would factor into u plus 3 times u minus 1. And so we would get two answers, u equals -3 and u equals 1. Now, of course, the solution that they're looking for is with the original question, which has the variable x, not u. So we'll need to replace u back, right? What does u equal? Well, u is square root of x. So this is square root of x equals -3, and square root of x equals 1. So now we can solve both of these equations by squaring both sides. So we get x equals -3 squared, which is 9. And here we would square both sides. So we get x equals 1. So now we have our solutions, x equals 9 and x equals 1. Of course, we could have also added 3, subtracted x, divided 2, and then squared both sides. But this is another way to do the problem so that you don't have to do that. It makes it a little bit quicker, okay? So let's go ahead and check both of these answers, right? X plus 2 times the square root of x minus 3, does that equal 0? So this is my first check. Square root of 9 is 3, so 2 times 3 would be 6. 9 plus 6 is 15. 15 minus 3 is 12, and 12 does not equal 0. So this is not a valid solution. Let's go ahead and check 1 now. Okay, 1 plus 2 times the square root of 1 minus 3, does that equal 0? That is the question. So square root of 1 would be 1. So 2 times 1 would be 2. 1 plus 2 is 3. 3 minus 3 is 0. 0 equals 0. Yes. So our solution is x equals 1. All right. Let's try one more, and then you guys can try one on your own. All right. So on this one, notice that we have some expression in the front. Now, do you notice that that expression is the same thing as this that's on the inside of the radical? So u will be this radical right here. We're going to replace u. We're going to replace that with the entire radical, x squared minus 3x. So u squared would be all of this squared, which would be x squared minus 3x. So as you can see, we're going to replace the x squared minus 3x with u. And then we will replace the entire square root here with u. So we're going to replace this with u squared, and then minus this with u. Okay, so now that we have u substituted in, we can go ahead and subtract 2 to bring that to the left-hand side. So I have u squared minus u minus 2. This would factor into u minus 2 times u plus 1. So we have two potential solutions here, u equals 2 and u equals negative 1. Again, you can't check u, right? Because the variable is x. The equation is with x. So we have to go ahead and replace u back. So u is the square root of x squared minus 3x. And again, we could do that over here as well, the square root of x squared minus 3x. And then now we can solve both of these separately. So I'm going to go ahead and square both sides. So I have x squared minus 3x equals 4. And then I can subtract 4 to bring that to the left-hand side. So I have x squared minus 3x minus 4 equals 0. And this would factor into x minus 4 times x plus 1. So I have two potential solutions here, either x equals 4 or x equals negative 1. Okay? And then on this equation, I could do the same thing, square both sides. So we end up with x squared. Actually, let me take it back a step. I could solve for this one, but do you notice that the equation is actually the square root of something equals a negative? And I could actually have noticed that over here as well. The square root of something equals a negative. That will never happen, right? The square root of something cannot equal a negative. So that's why this ended up not being a valid solution. So we can actually just from here, no matter what x is, when I take the square root of whatever's on the inside, it would never give me negative 1. So I could actually just toss that right away. So now we just have to check these two solutions and we'll verify that. So I'll check on x equals 4 first. And so using my original equation, 4 squared, I'll skip some of the steps, is 4 squared is not 64. Sorry. 4 squared is 16. And then negative 3 times 4 would be negative 12 minus the square root of x squared. So 4 squared would be 16 minus 3 times 4 is 12. Does that equal 2? Now, 16 minus 12 is 4. Square root of 4 is 2. 16 minus 12 would be, oops, I forgot. Or not forgot, but I can't really fit the minus there. So 16 minus 12 minus 2. Does that equal 2? Now 16 minus 12 is 4. 4 minus 2 is 2. So 2 equals 2. Yes, this checks out. 4 is a good and valid solution. All right, let's go ahead and check negative 1 next. Okay, now again, I'll skip some of the steps at the beginning. So I'm going to go ahead and check negative 1. Okay, so negative 1 squared would be positive 1. And negative 3 times negative 1 is positive 3. And then minus the square root of, again, negative 1 squared is positive 1. Negative 3 times negative 1 would be positive 3. And we're checking, does that equal 2? Now, 1 plus 3 is 4. The square root of 4 is 2. So this is 1 plus 3 minus 2. Does that equal 2? Now 1 plus 3 is 4. 4 minus 2 is 2. 2 equals 2. So this is good and also a valid solution as well. So we had two solutions on this one. Awesome. All right, so go ahead and pause this video now and try number 3 on your own. Okay, so let's take a look at number 3. Now, with number 3, we do have a quadratic in form, right? Remember, that will be u, and then this will be u squared, right? So I'm going to go ahead and replace u is the square root of x, and u squared would be square root of x squared, which would be just x. So I'm going to replace square root of x with u, and I'm going to replace x with u squared. So we have negative u squared plus 2 times u plus 8 equals 0. I'm going to go ahead and factor out a negative just so I have a positive for my quadratic term. So that will give me negative 2u minus 8. And then now I can factor this quadratic here. Now, multiplies to negative 8 adds to negative 2. 4 times negative 2. No, negative 4 times 2, negative 4 plus 2. So this will factor into u minus 4 times u plus 2. And now I can go ahead and see that u equals 4 and u equals negative 2. So now that we have u solved, right, we have to go ahead and replace u back. U is the square root of x, okay? So the square root of x equals 4, and the square root of x equals negative 2. And again, right, here we can square both sides, but actually if we just think about it, we can already cancel this out, because no matter what I get x as an answer here, the square root of that number would never give me a negative, right? It would give me, if it's a negative x, then it would give me I, right? But it would never give me a negative result. So this you could actually already toss out. That would give you an extraneous solution. Now, if the question was, find the extraneous solution, then you would actually want to solve for that. The extraneous solution would be x equals 4, right? Because you would square both sides. So the extraneous solution there is 4. If the question was, what is the extraneous solution? Then that would be the answer. But this question just asks us to solve, so we have to find the actual valid solution. So we would get that from here. We can go ahead and square both sides. So we have x equals 16. And again, I will just verify that by checking it. So negative x plus 2 times the square root of x plus 8, does that equal 0? And the square root of 16 is 4. 2 times 4 is 8. So we have negative 16 plus 8 plus 8. Negative 16 plus 8 plus 8 would give us 0. So yes, this is a good and valid solution. We are done. All right. The other type of quadratic in form that you could have is when you have a fraction exponent. Now, with these other problems, you could probably get around using u substitution, right? And instead, you can just like add x and subtract 8 and then divide 2 on both sides, and then you can square both sides. So you can get around using u substitution with these types of problems, but it's really, really beneficial and a lot quicker for these types of problems where you have a fraction exponent in more than one place, okay? Now, again, the idea with these is the same as the other one. You're going to find some u, right? And that u will be what's in the middle, right? U is x to the power of 1/3. Now, in the front, right, we have this variable, and that's actually u squared. If I take this and I raise that, x to the power of 1/3, I raise it to the power of 2, right, I would get x to the power of 2/3. So u squared is x to the power of 2/3. So I'm going to replace x to the power of 2/3 with u squared, and I'm going to replace x to the power of 1/3 with u. So my new equation written as u would be 2u squared minus 5u minus 3 equals 0. Now I can solve this like a regular quadratic. The coefficient is not 1, so I need to go ahead and rainbow over, right? Multiplies to equal negative 6, adds to equal negative 5, so that would be negative 1 and negative 6 and positive 1. So you could break up the middle, right? 2u squared minus 6u plus 1u minus 3 equals 0. Factoring out from the first 2u, that will give us u minus 3. And then from the back 2, we can't really factor out anything, so I'll just put a 1 as a placeholder. And then we could factor out from both of these terms the u minus 3. So factor out u minus 3, and that will give me 2u plus 1. Okay, so I have two potential solutions here, u equals 3 and u equals negative 1/2. Now that we have u, right, solve for, we need to go ahead and plug it back in so we can find what is x. which is really the question we're looking for, right? So I'm going to go ahead and replace u with what it is, which is x to the power 1/3. Okay, and then now I'm going to go ahead and solve for x by raising both sides, to the power of 3. So I'm going to raise both sides to the power of 3, and that would, power of power multiplies, right? 1/3 times 3 is 1. So this x to the power 1 equals 3 to the power of 3, which 3 to the power of 3 would be 27. 3 times 3 times 3 is 27. Okay, and then for this problem, we're going to do the same thing, raise both sides to the power of 3. So we get x equals -1 to the power of 3 would be +1, 2 to the power of 3 is 8. So we get 1/8. Okay, so now we can check this answer. And I'm going to be a little lazy and just plug it all into my calculator. So we have 2 times x, which I'm going to check 27 first, to the power of 2/3 minus 5 times x, which again is 27 to the power of 1/3 and minus 3. We got 0, so this is a good and valid solution. Let's check 1/8 next. So 2 times, parentheses, fraction 1/8 to the power of 2/3 minus 5, oops, that's a negative, minus 5, times the fraction x, which is the fraction 1/8, to the power of 1/3 and minus 3. Okay, now that gave me -5. -5 does not equal 0, so this is actually an extraneous solution. So the answer is 27. All right, let's try one more. Now, this one might seem like, oh, well, that's not going to work because 1/4 times 2 is 2/4. But yeah, but 2/4 is 1/2, right? So u is the x to the power 1/4, and then x to the power 1/4 raised to the power of 2, u squared, right? If I square this, I will get x to the power of 1/2. So I will replace x to the power of 1/2 with u squared. So this gets replaced with u squared, and x to the power of 1/4 gets replaced with u. So we have u squared minus 3u plus 2 equals 0. Okay, the coefficient is 1, so this factors very easily. Factors into u minus 2 times u minus 1. So we have two solutions, u equals 2 and u equals 1. Okay, so now we need to replace u back, right? U is x to the power of 1/4. So we have x to the power 1/4 equals 2, and again, u is x to the power 1/4. So we have x to the power 1/4 equals 1. All right, to get rid of that power 1/4, we're going to go ahead and raise both sides to the power of 4. That way, power of a power will multiply, and that will be 1. So we have x equals 2 to the power of 4, which is 16. Okay, and then over here, we're going to go ahead and do the same thing, raise both sides to the power of 4. That way, 1/4 times 4 would be a power of 1, and then 1 to the power of 4. 1 to the power of anything is just 1. So now let's go ahead and check. Now again, I could use my calculator, but I'm just going to do this one by hand. I don't think it will be that complex. So 16 to the power of 1/2, that's really the square root of 16, which is 4. And then minus 3 times 16 to the power 1/4 is the 4th root of 16, which is 2. And plus 2, does that equal 0? Well, -3 times 2 is -6. 4 minus 6 is -2. -2 plus 2 is 0. So yes, this is a good and valid solution. We can go ahead and box it. Next up, let's go ahead and check 1, right? Just because 1 is a solution doesn't mean the other one isn't. You could have more than 1. So we're going to go ahead and check 1. 1 to the power of anything is 1. Minus 3 times 1 to the power 1/4. Again, 1 to the power of anything is just 1. Plus 2. Does that equal 0? Well, let's see. 1 minus 3 is -2. -2 plus 2 is 0. 0 equals 0. So yes, that's also a good and valid solution. So we have two solutions on that one, 1 and 16. All right, so go ahead and pause this video now and try number 3 on your own. Okay, so let's go ahead and take a look at number 3. Now with number 3, we do have a u that's going to be x to the power of 2/3, okay? And I always like to verify this by squaring that and checking and making sure that it'll equal this one, right? Because this is supposed to be u squared. So let's see. If I raise this to the power of 2, right? If I square this, it would be x to the power of 2/3 times 2, which would be x to the power of 4/3. So yes, that checks out. So we have 3u squared plus 5u minus 2 equals 0. And again, we want to rainbow over if there is a coefficient in front. So I need multiplies to equal -6 and adds to equal +5. So on this one, it will be 6 times -1, 6 plus -1. So I will break up the middle, 3u squared plus 6u minus 1u minus 2 equals 0. And I could factor out 3u from the first two, which will give me u plus 2. And I could factor out a -1 from the last two, which will give me u plus 2. Okay, now I could factor out from both of these terms u plus 2, which will give me 3u minus 1. Okay, so I have two solutions, u equals -2 and u equals 1/3. Okay, so now let's go ahead and plug u back in. U is x to the power of 2/3. Okay, and now we need to solve both of those so we can get what does x equal, right? So I'm going to raise both sides to the reciprocal power of 3/2. And this cancels, okay, because it ends up being 1, power of 1. And then -2 to the power of 3/2, it's really -2 cubed, which is 8, and then the square root of that. So it's not going to be a whole number, okay? -2 to the power of 3, actually I should put -2 in parentheses, because if not, it's going to end up giving me a negative number, right? It's -2 to the power of 3, which is, let's do that one more time. I don't know why the calculator, maybe because I didn't fix it. -2 to the power of 3. Oh, actually, it's 3 copies. I'm sorry, guys, brain fart. So yes, that's -8. So we have the square root of -8. Okay, now let me just show you what it would have looked like if you had just plugged in -2. Anytime you have a negative, you should put it in parentheses. Okay, there we go. To the power of 3/2, just so you could see what it would give you. You see, it gives you a domain error because you're ending up taking the square root of a negative, right? So that means that there is no real solution. Okay, so this doesn't give me any real solution. No real solution from this one. All right. Over here, we have x to the power of 2/3, so I go ahead and raise both sides to the power of 3/2, and we end up with x equals 1/3 to the power of 3/2, and I'm just going to be lazy and use my calculator, to the power of 3/2, and we get a decimal. Okay, so we're going to go ahead and having to do this by actually distributing that power of 3 to each of them, and then writing the square root. So 1 to the power of 3 is 1, 3 to the power of 3 is 27, and then the index is 2, so this is the square root of this, right? So we have x equals square root of 1 over square root of 27. So I need to rationalize because I cannot have a square root in the denominator. So this will end up being the square root of 27 over 27, right? Because the square root of 1 is just 1. So that is our final answer. Okay, and we can go ahead and check that answer with our calculator would be the easiest, right? So 3 times, and we could use the fraction, square root of 27 over 27. And let's close that. And that is has the power of 4/3 to the power of 4/3 plus 5 times that same x value, which is this fraction, square root of 27 over 27 to the power of 2/3 minus 2. And that should give us 0. And it does. So that is a good and valid solution. Alrighty, so hopefully that was helpful, and you are now have another tool that you can use to solve these equations, and I hope you guys have a good day. I'll see you guys in the next video.